Today we're going to do a review for PC 5. The first type of problem, multiplying binomials, we have two terms, an x and a number, in each set of parentheses. We're going to use the box method to set up a 2 by 2 box and put these terms on the outside of the box. The signs come with them. We have an x here and a positive 2, an x and a negative 7, which are coming from up here. The next thing we do is we multiply row by column. So here, when we have x times x, each of these x terms has an invisible 1 as the exponent. And when you multiply them, you add those exponents together. So this gives you x squared. Then when I multiply row by column, I have x times 2, which gives me 2x, negative 7 times x, negative 7x, negative 7 times 2, which gives me negative 14. When I combine like terms, this diagonal is the only part of the box that has the same term. We have a 2 and a negative 7 that are both attached to an x. So if I consider what is 2 minus 7, that's negative 5. So when I combine like terms, this is my final answer. Heading over to the right, we have a similar thing going on with more negatives. So I'm going to set up my box. And on the outside, we'll put 4x and negative 2, because of this minus here. Negative x and minus 3, because those subtraction or negative symbols come with the numbers and the letters. And again, I multiply row by column. So the first thing I do is negative x times 4x. I can start with the numbers negative 1 times 4, which gives me negative 4. And then I kind of count up how many x's I have. Well, this is x to the first, and this is x to the first. So I have 2 of them. So this becomes x squared. Then when I take negative 3 times 4x, again I can multiply the numbers first. 4 times negative 3 is negative 12. And how many x's do I have? Just the 1. Negative x times negative 2. Remember, I do the numbers first. Negative 1 times negative 2 is a positive 2, and there's only one x. And finally, negative 3 times negative 2 is a positive 6. When I combine like terms, this diagonal contains the only two x terms in the problem. So I end up with negative 4x squared, and then I take negative 12x plus 2x, which gives me a negative 10x, and then I add 6, and this is my final answer. This problem looks different, but it's actually the same, because anything squared means you are multiplying it by itself. So this actually becomes 2x plus 4 times 2x plus 4, which means when I set up my box, I put 2x and 4 on the top and 2x and 4 on the side. 2 times 2 is 4. There are 2 x's, so I'll put a square. 4 times 2 is 8, 1x. 2 times 4 is 8, 1x. 4 times 4 is 16, no x's there. When I combine my like terms, I have 8x and 8x. So my final answer becomes 4x squared plus 16x plus 16. This next problem is a trinomial multiplied by a binomial, because in parentheses we have 3 terms instead of 2. It's a very similar setup, but slightly different. When we do our boxes, instead of having 2 by 2, we now set up a 3 by 2. And we have to put the 3 terms on this side and the 2 terms over here. Then we again multiply row by column. And for this row and column, it ends up being x multiplied by negative x squared. And this is a different problem than we've seen before. We can multiply the coefficients first, 1 times a negative 1. And now we count up how many x's we have. Well, we have x to the first power and x to the second power, So we add them together and we get negative 1x cubed, or just negative x cubed. The next row and column, I have negative 3 times negative 1, which gives me a positive 3. And how many x's do I have? Well, there's the x squared here at the top, and there's no x's on the row. Next up, I have x times 5x, so 5 times 1 gives me 5. There are 2 x's, so it's another x squared term. 5 times negative 3 is a negative 15, and there's only 1 x. 1 times negative 2 is a negative 2, and there's only 1 x. And finally, I have a negative 3 times a negative 2, which is a positive 6. When I combine like terms, I have 2 x squared terms, and I have 2 x terms. So I'm going to combine those before I get my final answer. The negative x cubed stays the same, but for x squared I have 5 plus 3, which is 8x squared. And for my x terms, I have negative 15 plus a negative 2, which gives me negative 17x. And for my constant, it's still 6. This last problem is a binomial times a binomial times a binomial. And you have to do this in 2 different steps. So first, we're going to multiply these first 2 binomials. We set up our box. 2x, 1x, negative 2. And I multiply rows by columns. 2x squared, negative 4x, x, and negative 2. I combine my like terms, which are my x terms, and I have 2x squared minus 3x, because it's negative 4 plus 1, minus 2. So I'm going to take this answer, and I'm going to multiply it by this negative 2x plus 2 from the top. And now it's just like the previous problem. We have a trinomial times a binomial. So if I set up a 3 by 2 box, (2x squared, negative 3x, negative 2, negative 2x, and positive 2), and I multiply rows by columns. So let's do just the coefficients first to practice. And that is negative 2 times 2 gives me a negative 4. 2 times 2 gives me 4. Negative 2 times negative 3 is a positive 6. 2 times negative 3 is a negative 6. Negative 2 times negative 2 is a positive 4. 2 times negative 2 is a negative 4. Let's go back and fill in our x terms. For this first box, we have x and x squared. So if we add those together, it's 1 plus 2, or x to the 3rd power. I have no x's multiplied by x squared, so the x squared gets copied down. X multiplied by x is 1 plus 1. And for these next 2 boxes, there's only 1 x, and the last one there's no x's. I'm going to circle my like terms. Notice this pattern of diagonals continues. Negative 4x cubed is the only x cubed term. For x squared, I'm going to take 6 plus 4 to give me 10x squared. And for my x's, it's 4 minus 6, or a negative 2. And my constant stays the same.